Hey, this is Mr. Caslin. Wanted to review a little Complete the Square. If you have an upcoming test or quiz that you need to work on this, remember Complete the Square is another method for solving a quadratic, where the highest degree is x to the second power. Now there's other ways of solving quadratics. You've learned factoring. You've learned quadratic formula. Complete the Square are for problems that don't factor, and you should get the same answer you get when you do quadratic formula. So let's review Complete the Square. Now we can't factor this, so we're going to take this constant and push it to the other side. So essentially we're adding 1 to both sides. So the sign of that term is opposite when it's on the other side. Okay, so that's equal to 1. Leave yourself some space because you know you're going to complete the square. My apologies, I'm using a mouse to write with, which I'm not real good at, so bear with me on that. Alright, now remember how to complete the square. You look at the middle number, which we call b, and you take half of it. Okay, so essentially you're dividing by 2, and then once you divide by 2 you're going to square it. So 8 divided by 2 is 4. 4 squared. The number you end up completing the square with is 16. Okay, now this is an equation, so whatever you do to the left-hand side, you have to do to the right-hand side also. Okay. Now we're going to simplify both sides. When you complete the square, this trinomial is going to become a binomial squared. The number you use in your binomial is half of the middle number. Okay, so it's half of that number, and it's the square root of that number. So x plus 4 squared is equal to x squared plus 8x plus 16. Alright, and then 1 plus 16 is 17. Alright, the reason you did this is put it into a binomial squared is because now we can solve this using square roots. Square roots and squares are opposites of one another. So in this left-hand side you get x plus 4. On the right-hand side, don't forget plus or minus. Whenever you're taking the square root of a number, when solving an equation, it's going to be plus or minus that number. Okay, now to finish this up, subtract 4 from each side. Okay, now the correct way to write this is you put the negative 4 in front. So it's negative 4 plus or minus the square root of 17. Okay, now the square root of 17, 17 is a prime number, so it can't be simplified. Okay, so that's your answer. Now there's ways to check your answer to see if they're correct. Okay, well, excuse me. Now one way to to check this, go ahead and graph x squared plus 8x minus 1. Okay, and then we're actually going to compute these two numbers. There's two numbers here. There's a negative 4 plus the square root of 17. So we'll note this down as what, 1.123. Okay, and then we're going to do negative 4 minus square root of 17. And that's about negative 8.123. Now remember, we just solved a quadratic. These are the zeros of the quadratic. Wow, that's terrible. Circle, let's try this again. There you go, it's a little better. So remember that the solutions are the zeros of the quadratics. If we go back and look at our calculator and we graph this, this is 1.123 is very close to 0, and the negative 8.123 is very close to negative 8. So it turns out that looks like 0 and negative 8 exactly, but it's not. Now, you could go to calc and find the zeros and confirm that those numbers are exact. But for now, this is good enough. It's about negative 8 and 0, and that's what we got. So use that calculator to double check your answers. Okay, now complete the square. This one's going to be a little more difficult because if you have a leading 3. if you have a leading coefficient, these problems, there's a couple things you want to watch out for. Okay, but we're going to complete the square. Let's push our 2 to the side. We get 3x squared plus 6x. Leave yourself some room to complete the square. You get a negative 2. Okay, now stop right here. Before you complete the square, you have to get rid of this 3. We're going to factor it out. Factor out of 3, you get x squared plus 2x. Leave some room is equal to negative 2. Okay, so the first thing you have to remember is factor out that leading coefficient after you've pushed your constant over to the other side. Okay, now you're ready to complete the square on the inside. You're going to x squared plus 2x. Now, the number you're going to place in here is, remember, take half of b. So 2 over 2 is 1, and then square 1. You still get 1. Okay, well, let's put it to the step down here. Okay, now, this is the other part you have to watch out for when the leading coefficient is something other than 1. Normally, if we add 1 to both sides, we add 1 to one side, we add 1 to the other. But be careful, because we distributed this 3, it's going to be 3 times 1. So when you're adding 1 here, you're really adding 3 to both sides. So again, in your notes, star this, put a highlight, do something so that you remember this step. Okay, now you're ready to turn this into a binomial squared. This is x plus 1 squared is equal to 1. Divide both sides by 3. Then you're ready to take the square root of both sides. You get x plus 1 is equal to, don't forget, plus or minus square root of 1/3. Okay, subtract 1 from both sides. You'll get a negative 1 plus or minus the square root of 1/3. Okay, again, use that calculator check to see what that would look like. Okay, so do the original function, which is 3x squared plus 6x plus 2. Look at the graph of that. You've got, I'm just going to take a guess right here, it looks like negative 1/2 and negative something close to negative 2. Alright, so we're going to input this in negative 1 minus the square root of 1/3. Okay, so we said there was something close to negative 2. It turns out that it's negative 1.5, and then negative 1 plus square root of 1 divided by 3. And we thought there was going to be something about negative 1/2. So that looks right. That looks reasonable. If you were to get like negative 6, well, that doesn't make sense with the graph. So it means you need to go back and double check your work. All right, one last thing. You could have a teacher pick you about your how you simplify your square roots. So let me put some space over here. We're going to look at this answer. Remember, 1 is a perfect square, so technically this is negative 1 plus or minus, let's see, the square root of 1/3. Remember, radical can be simplified in the numerator and denominator, so this is 1 over the square root of 3 But you can't have a radical in the denominator of your answer. Okay, do you remember the trick to get rid of that? You're going to multiply by 1, but you're going to disguise 1 as square root of 3 over 3. Okay, so now you're going to get, sorry, you're wondering why I changed that to a 1. Positive 1, I didn't mean to. Still a negative 1, plus or minus. Okay, this is a fraction, just multiply the numerator, multiply the denominator. Square root of 3 times square root of 3 simplifies to 3. So this answer and this answer are the same numbers. This one is considered to be complete simplified form. Okay, good luck with complete the square, and we'll talk to you later.